Hello friends, welcome to Susan and John MathTube. We are still on solving old question papers and this is part 4 and we are at question number 9. But in this video, we are going to additionally work out 2 more problems based on testing of hypothesis of 2 means. Okay, so first of all they are asking the procedure. Whenever they ask the procedure, you can be very happy because you don't have to do any calculation. All you have to do is you have to write the steps one by one. And it will be very nice if you explain the background. Explain the background in the sense what all things will be given or what all things are necessary to collect to conduct the test. So you can write things to collect or data to be collected, etc. Okay, so look at this. They are asking testing of hypothesis of 2 means for large sample. So basically you should have 2 variables, let's say x and y in general. And for x you have to collect a data whose size will be more than 30 and I am going to call it n1. And here the data size will be n2 and the size will be more than 30 so that they are both large samples. Remember, both of them must be large. Okay, now the things to be calculated are the arithmetic mean, the sample mean for the first part and the sample mean for the second one. So x1 bar, x2 bar. And the next thing, if population standard deviation is given, that's great. And if population standard deviation is not given, no need to worry. In large samples, we can find the sample standard deviation and use that approximately for the sample standard deviation. Remember, this trick works only for large sample. And S2, we can calculate the sample standard deviation and we can approximate it for sigma 2. Okay, so these are the things which you have to collect before you conduct an experiment. Okay, now we write the procedure. So step 1 means we have to write the hypothesis. The best method to write the hypothesis is, first of all, we write what we are trying to accomplish, what are we trying to prove, and that is called the alternative hypothesis. And the exact opposite will be our null hypothesis, that will be H0. Normally, the format is mu1 minus mu2 is equal to delta. It can be less than, it can be greater than according to the situation, and this is the most generalized format. And if you want the simple format, the format is mu1 is equal to mu2. But in exam it is better to write the most general method, that is mu1 minus mu2 is equal to delta. And if you write equal to, the alternative of course will be not equal to. And whenever we have not equal to, the test will be called two-tailed test. And another option is this can be less, this can be greater than or equal to. Another option is this can be greater, less than or equal to. And remember, if you see not equal to in alternative, you should always use the alternative to decide whether the test is right-tailed or left-tailed, etc., etc. Not equal to means two-tailed. And in two-tailed, we should always use alpha by 2 while calculating the tabulated value. And if it is greater than in the alternative, it means right-tailed. And if it is less than in the alternative, it means left-tailed. Okay, so step number 2. In step number 2, what we do is we declare the level of significance. Normally, it will be given in the question. And in the case when you are doing a research by yourself, you can decide. Depending on the importance of your research, you can decide the significance level. And remember, significance level in most of your books is denoted by alpha. And significance level has another name, risk level, the amount of risk involved in your prediction. Because the final stage of testing of hypothesis is you're going to give a prediction, you're going to predict something with some sort of confidence, and the complementary part is called significance, and significance is denoted by alpha, and you can declare that amount in the second step. Now the third step is the most important step, that is the calculation of test statistic. Anyway, in large sample we always go for normal distribution, so the test statistics will be Z calculated, and the formula is given by x1 bar minus x2 bar, the whole divided by root under sigma 1 square by n1 plus sigma 2 squared by n2. Now look at this, in the most general cases there will be minus delta, and delta means the right hand side of the null hypothesis. Okay, so what you do is with the given data you calculate Z calculated, and in step number 4 we go for the tabulated value. Now look at this, the tabulated value will always correspond to the test statistic. For example, in small sample you will be using T calculated. That means in the tabulated step you should calculate T tabulated. In ANOVA test you will be calculating F calculated. So in the tabulated section you should calculate F tabulated. Okay, anyway, here we are using normal because the sample is large, and the tabulated value will be Z significance level. Now one warning, this is only for left-tailed and right-tailed. In the case of two-tailed, we go for Z alpha by 2. You calculate this value, and we are interested only in the positive value of Z alpha, or in two-tailed Z alpha by 2. Now, if it is a left-tailed test, you draw a rough graph of the normal curve and mark the value that you get here, the tabulated value, on the left. And on the left means it will be on the negative side of the normal graph. So make sure you put minus and write mod Z alpha. At the same time, and the tail part will be marked reject, remaining part will be marked accept. And at the same time, if your test is right-tailed, you mark that Z alpha by 2, modulus Z alpha by 2 value on the right side of the graph. And the tail part will be reject and the remaining part will be accept. And if it is a two-tailed test, what you do is, in two-tailed test you calculated mod Z alpha by 2. You mark that value mod Z alpha by 2 in two-tailed, and you mark mod Z alpha by 2 here, and you mark reject on both tails and accept here. Okay, and now the last step, decision. In step number 5 you make a decision, and the decision will be comparing the tabulated value and the calculated value. I always feel the graphical method is easy. If the calculated value lies in the rejection zone, then reject H0. If the calculated value lies in the acceptance zone, then accept H0. The decision will be always about H0. I'll repeat. If the calculated value is in the rejection zone, reject H0. If the calculated value from step 3 is in the acceptance zone, accept H0. That's it. That's step number 5. Okay, now I'll make this more useful for you. I'm doing only one past paper question here, question number 9. I'm planning to work out 2 questions, one for small sample and one for large sample, so that it will be more beneficial for you. So let's go for the question. So look at this. The average hourly wages. Okay, so someone is doing research on the hourly wage paid by some factory. Okay, so the wages per hour, they tested for 150 workers in some factory, is just rupees 2.56, and the standard deviation is 1.08. The average wage for another plant is, okay, so the data is given. Now comes the main part. Can an applicant safely assume that the hourly wages paid by plant B is higher than that of plant A? Okay, now look at this. First of all, I'll tell you, they are collecting data from two different factories or two different companies or two plants of the same company. And you can notice that the sample size in plant A is more than 30. So clearly this is large sample. Same is the case for plant 2. So remember, both of them should be large. So this is large sample and 2 mean testing, because we are comparing one plant with another plant, or one health product with another health product, or one chemical with another chemical, or one experiment with another experiment. So basically this is large sample, the same thing, the same theory which we discussed just now. So this is large sample, see, the same thing. This is large sample and 2 mean testing. Okay, so I'm going to write the remaining data. Okay, the sample mean is given. The sample mean is given 2.56 and x2 bar 2.87. Sample standard deviation is given. Very good. Look at this. I told you we need population standard deviation, but no need to worry. Since it's a large sample testing, we can approximately use sample standard deviation for the population standard deviation. And sample standard deviation for plant 2 is given to be how much? 1.28. And that means sigma 2 is approximately 1.28. So we have all the necessary things that we need. Now one very, very important thing. What are we going to prove or disprove? Okay, now look at this. Someone is asking, with this data, can we, with 95% confidence you have to predict, can we assume that plan B is paying more than that of plan A? Okay, so look at this. What I'm going to do is, I'm going to set up the hypothesis. And I always feel it is better to write the alternative hypothesis when we have two means. When we are dealing with two parameters, two means, it is better to write the alternative. Remember, alternative means whatever you are going to prove or disprove with the help of the sample data. Whatever you are going to prove or disprove with the help of sample data. Okay, now one very important thing. I'm going to assume mu1 means, the assumption is written here. mu1 means the salary, the average hourly wage for plant 1, and mu2 means the same stuff for plant 2. Now we are trying to prove, or with the help of data, what are we trying to prove? We are proving, or we are trying to check plan B gives more. Plan B gives more means, yeah, it will be in this format. Okay, now H0 will be very easy to write. Just use the complement symbol. Okay, now I told you the most generalized format is not like this. We don't write it on, it's okay, no problem. Even if you write like this, they are going to give you a mark. But the most generalized format is, we take everything to the left side and write it in this format, and the value just I got on the right side will be delta, and H1 is mu1 minus mu2 less than 0. Now look at this, the alternative has a symbol less than, so I know that the test is left-tailed test. So the test is left-tailed test. So I hope you are okay with this. Okay, now comes step number 2. In step number 2, what we do is we declare the confidence and significance. And here the significance is given to be 0.05. Now remember, if the test was two-tailed, I should write alpha by 2 here. But this is not a two-tailed test, this is a left-tailed or right-tailed test. So I don't have to worry about alpha by 2. Now the third and the most important part, calculation. So I hope you are ready with your calculator. And since it is large sample, I am going to use the normal distribution. The test statistics will be set calculated. First write the formula. I will use the general formula, sigma 1 squared by n1 plus sigma 2 squared by n2. Now plug in all these things. That is set calculated is equal to 2.56 minus 2.87, the whole divided by 1.08 squared by 150 plus 1.28 squared by 200. I got the value, you can check it, you can double check it, minus 2.45. Okay, so that's a calculated value. Now we go for the tabulated value. Okay, tabulated value means you have to look at the normal distribution table, and I'm going to calculate the positive value, that will be Z alpha. Once more I am telling you, if the test was two-tailed, you should go for Z alpha by 2, and that will be mod Z 0.05. Now we have the table here, we are going to go do inverse calculation. Wait a minute, I'm really happy. It's a standard value 0.05, 1.645. So the value is 1.645. Now look at this, make a rough graph. Make a rough graph of our normal distribution if we use Z, T distribution if we use T, F distribution if we go for ANOVA, and chi-square distribution if we go for chi-square. If it is left-tailed, remember in ANOVA and chi-square there is nothing called left-tailed, right-tailed. It will be always right-tailed. Yeah, if it is left-tailed, here it is left-tailed, I have to mark on the left side 1.645, and I will mark reject, and remaining part I will mark accept. Now one simple thing to do, I have to compare the calculated value. What was my calculated value? Minus 2.45. And look at the picture, that will be much easier. 2.45 with a negative is in the rejection region. So we will write the calculated value is in the rejection region. Hence, we reject H0. That means we tend to accept H1. Okay, so that's it. You can conclude like this, or you can write we are 95% confident that, or we can safely assume that plan B is paying higher wages than plan A. Okay, now let's go for the last question. And in this case, it is small sample. So you can read the question. It looks kind of similar, but you can notice this N1 and N2. See, small sample. Both are less than 30, so we have to use small sample testing. And the confidence level is given 95%, and the data given is about lung damage. So the research people have somehow measured the lung damage. So they have the lung damage for smokers and lung damage for non-smokers. You remember one thing, even people who do not smoke will be subjected to lung damage because of pollution. So they have measured the lung damage for the people who smoke and people who do not smoke. And they are trying to find a conclusion for, okay, smokers have greater lung damage. So that is what they want to prove or disprove from this sample. So like I told you before, we will write the alternative hypothesis first. I'm going to use mu1 for the the smoker population and mu2 for the non-smoker population. And we have to prove that, or they are trying to prove that, or their claim is smokers have more lung damage. So it should be like this. That means the null hypothesis will be automatically mu1 less than or equal to mu2. Now let's put it in the standard format. H0 mu1 minus mu2 less than or equal to 0, and H1 mu1 minus mu2 greater than 0. So clearly this is a right tail test. So there are two parameters, so two mean testing and small sample. So that's the same thing written here. So H1 mu1 minus mu2 greater than 0. And don't search for delta, the right hand side is delta. Normally in your question paper they tend to put delta 0, but in one or two question papers I saw delta being a non-zero number. Okay, now step 2, the level of significance. Look at this, the confidence level is given 95%, and that means the level of significance or the risk level will be 5%. So alpha equal to 5%. Now calculation. Now look at this, in 2 mean small sample, calculation is a little bit lengthy. And remember, small sample means we will use t distribution. So anyway, first of all we will calculate something called pooled standard deviation. Pooling means the combined standard deviation. And the formula is n1 minus 1 into s1 square, etc., etc. You can see, you can calculate. And don't forget to take square root, we need SP. And the test statistic, of course, it will be T. Small sample means it will be T. It goes like x1 bar minus x2 bar or x bar minus y bar. And pooled standard deviation, the value here, 1 by n1, 1 by n2, calculate. Now, another very important thing is, we are dealing with small samples, so we go for t distribution. So the tabulated value should be taken from t distribution. And remember, when you use t distribution, the degree of freedom will be n minus 1. Now we have two variables here, so it will be like n1 minus 1 plus n2 minus 1. So remember, the degree of freedom will be n1 minus 1, n2 minus 1. So look at this, that is why we got n1 plus n2 minus 2. And if it is two-tailed, same story, it will be alpha by 2. But this is right tail, not two-tailed. And I got this value from the t distribution. Now as usual, draw the rough t distribution table. And since it is right-tailed, I am marking this value on the right. And just like I promised, we will write reject on the tail, the right tail, and the remaining part accept. And there is only one thing to do. Decision means you have to compare this value, or you have to spot this value on the graph. Anyway, the value is in the rejection region, so we reject H0. So we reject H0 means we are accepting H1, and H1 means, yeah, we are right. We are 95% confident that smokers have greater lung damage. Okay, I'm going to wind up this video right now. I'll be back with the next video very soon, and in that video we'll go for question number 10 from 2076 question paper, and we'll learn the paired t-test. We will learn the paired t-test. So till then, my friends, bye.